All right. Respected Chair, Speaker, participants, ladies and gentlemen, Namaste, good evening, good afternoon, good morning to everyone watching us right now from different parts of the world. Welcome to the webinar hosted by Center for Diplomacy and Development. This webinar is supported by Neman, Khabar Hub, Kitab Yatra, and DC Nepal. It is my privilege to be the moderator of this webinar. I, Purnima Subedi, on behalf of CDD, would like to extend a very warm welcome to all the respected participants and the respected speaker. Now, let me give a brief introduction of Center for Diplomacy and Development. CDD is a think tank under Track 2 Diplomacy, which was established in February 2018 for undertaking several activities like holding seminars, workshops, hosting talk programs, undertaking research studies, creating forums, contributing to promote mutual understanding between foreign community and Nepali community. Today's webinar is yet another important program hosted by CDD after the outbreak of COVID-19 pandemic. The topic of today's webinar is application of remote sensing in Nepalese agriculture. Today, we have with us a very experienced academic and dynamic personality as the speaker. Before we start this webinar, I would like to mention a few rules and code of conducts to be followed. Our speaker can mute and unmute themselves whenever they wish to speak, share the slides, or record the webinar. Speaker will be given 40 minutes for the presentation. We will not take any questions in between the presentation. However, we'll take a few questions at the end of the webinar. All the participants' mic will be muted, so the questions should be put forward in the Zoom chat box or in the comment section of Facebook Live. Please keep your questions short, precise, and relevant to the topic. Long and irrelevant questions will be clubbed. Now, may I invite Mr. Mohan Krishna Shrestha, former ambassador of Nepal to France and founder president of CDD, to give his welcome remarks. Over to you, sir.
Thank you, Purnima ji. Dr. Tilak Bahadur Shrestha, our speaker today, distinguished audience at home and abroad. I wish namaste, good evening, good afternoon, and good morning to all our listeners in different time zones. We thank you all for your kind attendance at this webinar. And let me also pray for your safety and well-being during such pandemic situation. Distinguished guests, as you know, Center for Diplomacy and Development, since its establishment in 2018, has been effortful to host various types of programs in diplomacy and other developmental areas. Since the outbreak of Corona, we have been undertaking activities on home-based, resorting to webinars. Today also, this is yet another effort to host this important webinar. As we all know that Nepal is an agriculture country, agriculture sector is the backbone of our economy. About 70% of the population are engaged in various agricultural activities, and more than 66% of the exportable goods comes from this sector. Moreover, more than 40% of the government's revenue comes from agriculture sector. All these figures indicate how important is agriculture sector in our country. I remember during my youthful days, Nepal used to export rice, but situation has been reversed. Now we import rice and other edible cereals for billions of rupees each year. It will continue if we could not reverse the trend, increasing our productivity. Another important travesty is that despite such importance, agriculture sector is still being plagued by several problems like fragmentation of the land, lack of irrigation facilities, adequate chemical fertilizers, and modern technology in the farming. Truth is that we need to modernize our agriculture sector for increasing productivity, introducing modern methods of farming. Distinguished audience, today we have with us an eminent academician, Dr. Tilak Bahadur Shrestha, who teaches and lives in USA. My introduction with Dr. Shrestha has not been long, but during our talks, I was enormously impressed by Dr. Shrestha. I thought in the area in which Dr. Shrestha has gained so much competence might be useful for our country in one or another way. I therefore requested Dr. Shrestha to appear in a webinar and give his ideas how remote sensing can be useful for our country. He happily agreed and consented to participate in today's webinar. Taking this opportunity on behalf of CDD and on my own, I would like to extend my cordial thanks and appreciation to Dr. Shrestha for his cooperation and contribution. Remote sensing is a new concept in our country, and I hope we'll enjoy hearing Dr. Shrestha's presentation and enrich our knowledge how our agriculture sector might benefit from this discipline. I thank you all for attending our webinar today.
Thank you, sir. Now, continuing the program, now I would like to give a brief introduction of our eminent speaker for today, Dr. Tilak Bahadur Shrestha, who lives in USA. Dr. Shrestha has a PhD in geography from University of Florida. He specializes in dissertation, remote sensing, land cover classification, texture measures, and accuracy analysis. Moreover, he has double master degrees in science and technology from Florida State University and Andhra University, India. He has a professional experience in teaching, research, and production in remote sensing and photogrammetry. Plus, in teaching, Dr. Shrestha has also experience in LIDAR, GIS, and statistical analysis. He has constantly planned and accomplished complex projects. He has also taught STEM, science, technology, engineering, and mathematics in the US Federal TRIO program. He has an expertise in teaching and research at Kentucky State University, Alabama A&M University, and University of Memphis. Dr. Shrestha has also project experiences in Optimal Geomatics Inc., Erotic LLC, Earth Mapping International, and PAR Government System Corporation. He is a member of Geography Honor Society, Scout Organization, and he is fluent in 4 languages. Dr. Tilak has won several awards in speaking and debates. He also takes deep interest in chess, table tennis, boxing, and karate. Over to you, sir.
My turn now.
Yes, sir. Yes, sir.
Hello, namaste to everybody. Thanks for a really generous introduction. I don't deserve that one. But anyway, basically what we're going to do today is quickly talk about what this remote sensing technology is. Just a brief introduction. And how can we use in Nepal? And then especially if you specialize into, say, agriculture, then how it can be done. Basically, remote sensing is not answer to all of the questions. It has to work with along with other field. To give you a simile, it will be something like X-ray technology in the medicine. It will not tell you exactly what disease it is, but for the doctors, if they look at the X-ray, then accompanying with the other information, then you can tell, it really helps, like something of that nature. Basically, when we talk about remote sensing, we have Earth like this, and then the satellites are moving around this one, and it will sense the surface. And so we have got different electromagnetic waves, which is you get information, and then you do lots of analysis out of those numbers. So basically, lots of statistics and math oriented, plus physics and the geology, geography, things like that. And basically remote sensing is used in many fields. Say number one is actually a defense, security kind of stuff, but they are really expensive and it's not really available. But in the commercial side, it's used in, say, forestry, agriculture, urban and remote urban planning, geography, surveying, and the number of fields on that one. But anyway, if you measure only information from a distance, that we call the remote sensing. So, so we have like a different platform to get information. Say, for example, you have here we got like from the satellite, and then you also can have information from like the planes, and then we have something like this from the plane. You take the photos, so this will be like a photogrammetry side, and then you also have a lidar. So from the laser, you measure the distances, all the spots of light. This is from the lidar, and so basically we can use in different things. Say geodesy, you have got remote sensing, you got physical science, and the mathematical logics, and a bunch of different things. And so you have got number of information planes. So you have got one surveying plane. On that one, you may add, say, information on the, say, forestry, then information on the agriculture, then on top of that, say, water, hydrology, and so on and so forth. So you have got layers and layers and layers of the information, and then you combine them together, and so that you can have other kind of things, the information you are looking for. Now, the remote sensing has both advantage and limitations. Now, in the advantage side, it is actually unobtrusive, means that the people would not know that you are taking information. And the second one is it can see more than our eyes can see. For example, our eyes can see from say blue, green, and red. Before that, you cannot see like ultraviolet and also infrared. You cannot see them, but the remote sensing can see that one. So that way, the range of information you can gather from remote sensing is much more than what you can actually see in the field. So that's a really good advantage. But in the negative side, we are culturally, attuned to say, oh, here's the grass, and here's the say, some kind of green leaf or vegetation. We can tell directly, but the remote sensing cannot tell that because both of them look like green, right? And so that's a negative part of that, because the texture and other information is innate in our system. Our eyes can differentiate those things, but the remote sensing cannot distinguish them. And also, because it sounds like a rocket science, it sounds like great technology. So lots of people tend to think this one is the medicine for all the purpose. So you have to slightly balance the overselling of the capacities. Okay. Now, here is a typical image. So here you have got image with zero point 0.5 by zero point 0.5 meter, resolution. And now here you go like a 10 meter by 10 meter, and here you go 40 by 40 kind of stuff. And so, depending on what accuracy you are looking at, for example, if you're talking about urban planning, then you need this kind of, accuracy, because you need to see all the differences. But suppose you are talking about forestry, then you don't need this kind of accuracy, but something like this will help. Now, suppose you are talking about oceans or say cloud and kind of stuff, then you don't even need this. You may work with this. So this is important because this takes lots and lots of, the what's called that, the size of the file and the soil to process is more difficult, but it depends on what kind of project you are working. So you have to define the accuracy or resolution of your project. And now basically this is where comes the one. Now if you look at, this is the electromagnetic wavelength. So here you go. This will be this range. This range is where you can see. So this blue, yellow, red, this is what you can see with your eyes. And before, so this is say zero point 0.4 micrometer to say 0.7 micrometer. This is the range of electromagnetic wave you can see with your eyes. And before that, so that could be like ultraviolet. And after that, you have got the infrared, and then it's come like a cloud, and so on and so forth, thermal radiation, and so on and so forth. And now the atmosphere does absorb lots of them. And so this is the absorption side. Only the reflectance is only so much. So it's a very little reflect out of this. But in this case, there are lots of reflected out. So let me put one more time. In this electromagnetic wave range, this side you have lots of reflection. In this case, you have very, very little all absorption, very little reflection. And so the idea is to get information where you can get, and just ignore where you cannot get any information out of that. And so typically your eye is from this range, which is about say 0.4 to 0.7 micrometer, and here's a cloud and so on and so forth. Now, this is where the different bands from the satellite get information. Suppose you are talking about Aster satellites. So it has the three range to get from your eyes, and then you got the micrometers, say ones, and then you have got like infrared ones. So suppose you take Landsat, satellite, it has six bands, say seven bands, and then one, two, three, something you can see, your visible range, here's the infrared, and then there are two more infrareds and the normal one. So different satellites gathers information from different range where the atmosphere allows the range of the electromagnetic waves to be reflected. Now there are bunch of satellites in getting information. So I'm just giving a quick note of that. So this is the digital globe, plates, spots. This is a French one, and then you got landside ones. So there are lots of them. So I'm just giving you a few samples. And why we are talking about mostly spot and the landside is because some of them are freely available. So if you're looking into, say, college education and other spots, we normally tend to get from landside. But if you want to do more work, and then if you require, then you have to go for some other satellite information, which is a little expensive. You have to pay for it. However, it depends upon the project. Sometimes you can get away with freely available images. Sometimes you can't have it.
A lot of analytics going on.
Now, if you look at the different countries, the United States is the number one country with so many satellites, and the second comes the Soviet Union, and then comes this Russia, the same thing. I mean, this is before in 1991, and then you got China, then Japan, the United Kingdom, then India, and so on and so forth. So for us, the cheaper one you get from India, even though they have a limited capacity for that one. Then from China also, the most we can get from United States also. So you have to explore what kind of information you are looking for, and then you see if any of them can be procured freely. You know, why you pay money for that, and then when it is necessary that well, we need to have this kind of accuracy. Then you may have to pay for it, and then shop around if which company might sell you cheaper. Now, basically, what it does, one more time again, this 400 is a nanometer, which is a micrometer, and from this blue, there is somebody, not mute, I guess, from 0.5 micrometer to 5. So this is the visible range, and then comes the infrared and so on and so forth. Now, we have the different surface has a different properties, reflection. So if you look at the concrete, this is how it will reflect. Now, suppose you take say grass, then this is how the grass will reflect. And suppose you take the sand, then sand will reflect like this, right? And so if you have to figure out the difference between the sand and the say grass, then you have to look at this curve and then this curve and figure out the technique to separate them out. And so you have got all different types of surfaces in our surface, which will have a different reflection capacities or the properties. And then you look at them and figure out that which classes you have to differentiate out, look at their properties, and then figure out that some kind of techniques to them separate them out. And this is a typical the way the satellite provides you. For example, this one is the Landsat. Send 2013. You have got all the different bands. Okay, so let me go back the ones. So different bands will be band here, band here, band here, band here, and so on and so forth. There are different bands along this line, and so you have got say if you take a blue, this is 0.45 to 0.05 micrometer, and then 30-meter resolution. So there are different bands, and then these two are for the normal, usually for this Earth surface from here, and so on and so forth. So we got all these properties you can collect from these different satellites. So here's the one typical, the imagery you collect from the remote sensing. So this is not the real color. This is the artificial color you get out of say from the satellite. And this is from the Kentucky State University. So this is the Kentucky State University. Because I was here, so I thought let me show you for this one. And then now basically now what happens in now up to that point is introduction. So let me go a little more technical. Now, suppose you take a vegetation. In that case, the things what we have to figure out is that which one has more vegetation. So then it comes like a different types of indexes comes along picture. One of the standard used called the NDVI. This is only one of the, there are lots of them. It's called the normalized difference vegetation index. So what it does, it takes the near infrared minus red and near infrared plus red and divides. So this number gives you the greenness of the or the amount of vegetation in the available in the surface, right? Now, this is one in the example of the indexes. Now there are lots of them. So I'm just giving one earlier. So you got brightness, greenness, yellow, non-search, brightness. I mean, there are a bunch of ones, and then you got lots of, indicators and lots of, parameters to collect them. And so basically what we have to do is that depending on the kind of the work you are trying to do, you have to figure out which indexes you are interested. And then you work, suppose I'm going to work with, say, with the agriculture, then I will sit down with the agriculture, the person, then I will ask him what the agricultural product you are interested. And then we'll figure out which kind of indexes he is interested. And then I will make some kind of like a formula or the one and put this one to get the indexes he is interested. And so now this is typically how it is done. Say soil and atmospheric resistant vegetation. So this is the formula for that. And for the enhanced vegetation index, this is the formula for that. And so there are lots of indices. Now, this may be something out of blue for most of the people, but for the people working in the agricultural field, they should know that what they are interested. So even though I'm just throwing up just to show the kind of indices we're going to work with remote sensing. Now, we use remote sensing in the different perspectives. For example, we have different models we have to make. Say global carbon cycle. That one we have to work with the foresters and what's called that ecologists, biology and biochemistry ecosystems. In all of these fields, the remote sensing is used as a technology to help them. Third, say global water and energy cycle, climate variability and prediction, atmospheric chemistry, characteristics of the solid earth, that means the geodesy, population estimation, monitoring land use change and natural hazards. Now, the remote sensing does not tell you the exact number, so you always have to work with other experts. Say, for example, population estimation. Okay. Now, when we talk about population estimation, the remote sensing will not tell you how many people are there. They won't tell you. However, what it does is it look at the change in the urbanization. And then you work with the population expert that in so and so year that was urbanization and so many people after say 5-10 years, so much urbanization, what's the trend? And then it will tell you the range of the urbanization and which will help in estimating the population. It will not count you the per head. Now, this is how the accuracy of the remote techniques are needed. Now, if you look at this side, you need really a precise, the information. If you look at that side, you don't need that kind of, a broad band is good enough. So this side, broad band is good enough. This side, you need really accuracy. So if you're looking at, say, emergency response, in that case, broad information is not good enough. You have to have a very precise one. Similarly, if you're talking about precision agriculture, you need more precise. Now, what do you mean by precision agriculture? Basically, in the California and other states, there are agricultural fields miles and miles long. And so to figure out where they have water, where there's no water, and so on and so forth, you cannot run around to find that. Now, this information maybe not, good for, not that useful because we don't have miles and miles of long, say arid land. But however, if in case we have, then you use this one. Say land use land cover, so the whole range is good enough, geology good enough kind of stuff. So it depends on what kind of accuracy you need. This will give you some kind of idea. Now, for example, weather prediction, you don't need that accurate. Say climate prediction, you don't need that accurate. Even a broad information will help. But otherwise, in this side, then you need more. And now, in terms of agriculture, we have got the crop types, yields also. That's also need to be taken care of. Now, let me quickly throw in Nepal here. This is Nepal, quickly mapped once. Here you go. Now, this is Nepal here, over here. Now, one piece, one color over here is one Landsat image. So here's the one Landsat image. Then you have got another Landsat image, and then you got another Landsat image, and so on and so forth. So to cover the whole of Nepal, you need 13 images to cover one. But I'm talking about from land side. However, if you use other satellite system, then you have to have other kinds of numbers comes out of this. I'm quoting this as an example, and because this is freely available, so in case you are interested to make a project for the students, this is the best one that I know of, because this you don't have to pay for it. And now I'm concentrating only. This is the Kathmandu Valley, and this is how the Bagmati River flows down. So I'm coming to only a part of that. Now this is how it will look, the real image, how it look like by the satellite. So this is the Kathmandu Valley. Okay, you can see the kind of like brownish patch in between, and then all the points over there. That's the Kathmandu Valley here. And now if you look at from remote sensing, this is how it look like this. So you have got all the red ones from infrared, because the radiation sends a lot more infrared out than the green blue. And so if you look at from the broad perspective, you see this kind of color. So this is all the false color, means this is not what your eye will see. Now, what do we, I'm going to quickly go to this. Now, what kind of strategy we can use to use this remote sensing techniques? Now, first, you have to define what kind of data you are interested. And so there are lots of interests will be there. Say, foresters will have their own, the interest, agriculture will have their own interest, geology, urban planning, meteorology, and so on and so forth. There are lots of them. For example, here, geography, agriculture, geology, forestry, hydrology, meteorology, urban planning, security, and so on and so forth. So what we have to do, first, bring all those interested and exactly the questions they are interested. Because lots of time, suppose you say geology, suppose I tell them that this is this kind of the tree, they are not interested. They are interested in what kind of rocks it was, right? And so you have to bring all the interests coming together. And then the second part, the third part will be you have to have the sample point collection. So basically what happens is, suppose you have the information from one spot, that may be anything. Suppose I see a green patch. Now, this green patch, is it, broccoli, or is it a grass? I cannot tell that. The computer cannot tell that. However, suppose somebody stands up here and say, okay, here is the broccoli, or say a cauliflower. In that case, then you can generalize that information to others using remote sensing. And so if you have to have a, say for agriculture, then the information will be first geography information, the sample points all over the Nepal, which is very simple. So you have to build one side, one time, and that's it. That's it, good for all the time. And then different seasons, agricultural stages, and the water, and so on and so forth. So you have to have those kinds of information to generalize the information you get from satellite. Yeah, I think somebody need to mute their ones. Okay, here we go. one typical example would be like say Indian Space Research Organization. So what they have done, agriculture, inland fishery, pest disease, soil mapping, I mean the water resource monitoring, global club, and so the bunch of them, they put them together. And then of course the main focus is the agriculture. And so the uses and the kind of interest data there from all this information, they put them together to help the agriculture. So we have also have to develop this kind of a program. However, we don't have to work too hard because almost other developed countries, including India and China, United States, have already done this kind of job. So what we have to do is um, copy their program and then adjust to our need. So let me repeat again. This is how we should go, but we don't have to work all the things by ourselves. All we got to do is copy their programs and their projects and then adjust to our need. And now one more time, there are different layers of the information you have to, provide, say, geodetic control. You have got, say, for transportation, you got the boundary, like Jilla, districts, and all kinds of hydrology. So, vegetation, soil, geology, all cultural, demography, and so on and so on. So you have layer and layer and layer of the spatial data. Then you put them together like this. And then you use which layers to put them together. So you have to, the combination of this data will need to do the other basic research. And the remote sensing comes in the picture to get all the layers and layers of data. And this one is one of the Americans have figured out, the project called the land use and land cover classes. So first level, broadly, say urban built-up ones, agriculture, rangeland, water, and so on so. So you have got a bunch of first level, and then each of them are again broken down into different layers and so on. So you have got level 1, level 2, level 3, level 4, and so on and so forth. So basically what happens is first you break down the land cover as urban, forest, water body, plain, and so on and so, just broad. And after that, each of them are again broken down into, say, residential, commercial, industry, and so on and so forth. And then you again break down. So you have got like a bunch of levels and bunch of land use covers. And in each of the ones, depending on how accurate you need, you may have to go to, somebody may have to go to a field, measure directly, and then use the remote sensing to generalize. So this is what we're going to do. And then this is NLCD, the same kind of thing with a slightly different perspective. So there is not only one kind of land cover classes, there are a number of them. In this case, also the same thing. We don't have to develop our own. What we got to do is the copy from other countries and then adjust to our need. So one of the things what I've done, so this is I'm giving example from United States. So what they have done is like they have brought 10 members of a consortium. So the 10 of the American organizations came together. Oh, here you go. Bureau of the Land Management, Environmental Protection Agency, National Aeronautical and Space Administration, National Agricultural Statistics Survey, Oceanic Atmosphere Administration, Army, a crop of engineers, U.S. Fish and Wildlife, Forest Service, and Geological, and so on and so forth. So there are 10 of them. So they came together and said, okay, this is the information we are interested, and some of them are common for all, some of them are not common to all. However, they put them together and then came with the land cover systems they are interested, so that the one measurement of the land cover system is useful to all, even though the information get will not necessarily useful to all of them, but there is a commonality. Also, if you have a common land cover information, then they can communicate. Otherwise, they are talking about apples and oranges, and there is nothing in common to talk about. But if you develop one system, then they can communicate and use each other. And then what we in Nepal, what we have to do, we have to have a sample points from all over Nepal. Now, this is not very expensive thing because all you got to do is one time, and it's very easy. All you got to do is, this is the XY coordinate, and this is what I see. That's all. Okay. And so if you can have a bunch of reference points, and then the remote sensing will generalize from the direct observation in the ground. Now, you can look at the remote sensing and then figure out also. You can do that without the ground point, but then that is not that accurate. So for the higher accuracy, if you can subordinate your data from the ground point of direct observation, that's really good. Let me quickly conclude. It is really good, like for the government and educational institutes and so on and so forth, and then we can put them together and really useful in a different field. It is not very expensive. The remote sensing at the outset, it is little expensive at the beginning, but it is not that expensive in large term. Say, for example, if you have to do survey, people have to go measure all kinds of stuff. Remote sensing does that in one shot. So it is really good technology, but it does not tell everything. It's like, again, let me repeat my earlier statement, that it is something like X-ray technology in the medical science. It will not tell you exactly what disease it is, but it really helps the doctors. So today, doctors will not be able to do a whole lot of work without X-ray on the side. So this is the source of the ones. And this is supported to, when I did this research in the Kentucky State University, it was supported by United States Department of Agriculture and so on and so forth. And this one, we got the award for that. This is the award number, we got this one, and so on and so forth. Thank you and namaste. Now, for now, I got 40 minutes, so 37 p.m., not bad. I'm in the right on time. If you got any questions, I'll be very happy to respond to. Thank you, sir. Thank you, ma'am.
Thank you, sir. Definitely, sir, remote sensing is such an advanced and interesting technology which can pave its way in Nepalese agriculture and do wonders in our country's agriculture scenario. Now we're moving towards the second half of the webinar. So the floor is open for questions. We'll take a few questions directed to the speaker. All the participants' mic will be muted. So please put your questions in the Zoom chat box or in the Facebook Live. I will check our Facebook Live and then see if there's any questions there. Meanwhile, if we have any questions right here, we can please share it on the chat box. We're patiently waiting for questions. All right, since we don't have any questions coming in the chat box, if anybody prefers to unmute themselves and ask a relevant question, you can speak up. Do we have any questions? Since this topic is so advanced, I think it's new to everybody listening right now. So I would like to skip this session right now. Now, continuing the program, I would like to invite Chair Mr. Mohan Krishna Shrestha to conclude the webinar. Since we don't have any questions right now, we might take questions at the end of the session.
Is okay, Purnima?
Is that okay? Okay. Mohan sir, we cannot. Yeah, we can see you now.
Okay, is okay now?
Yes, sir.
Okay, thank you. First of all, I'd like to thank Dr. Shrestha for his very nice presentation. Of course, for almost all of us, such remote sensing is a very technical subject, and it's not easy for us to understand exactly such a topic very easily. But however, what I understood that Dr. Srestha has made a very lucid presentation. First, he presented in the technical parts what is a remote sensing in the very technical words and with diagrams. That is very good. But for those people who have good knowledge of this subject, it will be a very good stimulus for them to understand what Dr. Srestha presented. Then what I understood that this remote sensing is, of course, is too technical for us, but it has a wider application even in a country like ours, where modern technology is not that much used. According to the presentation I heard from Dr. Srestha, this remote sensing technology can be used in many areas of our national lives, not only agriculture, but in the forestry, geology, meteorology, and many even security. So this is the impression I have got it, and I think, of course, what is the state of remote sensing activities in our country? I really don't know right now, but I think this subject can be introduced in Nepal. As Dr. Srestha has said, this is might be little expensive for a country like Nepal in the beginning, but later on it is not that expensive. It will be very, in view of its usage, it will be cheaper for Nepal to use this technology, and it's a wider application in many national lives, many areas of national life will be very useful for us. That is the impression I got it. Of course, I cannot understand all what Dr. Srestha has said because I come from diplomacy and this is purely a technical subject. But my impression is that this is a really good subject for us. And now we have a very eminent person like Dr. Srestha. We can ask him, we can contact him, we can get his guidance, knowledge in this field when the government or private sector or some other institutions might need knowledge about this field in our for the use in our country. That will be very useful for our country. What that is my impression. And his paper, we CDD has got a copy of his paper, which will be in our archive, and it will be very useful for our country in the future. And we also we are going to keep upload this presentation at the YouTube also, and it is also being broadcast lively on the Facebook also. Those who are attending, those who are listening, they can avail of this opportunity. But if those who have missed, they can see this presentation later in the YouTube also, and get more knowledge about this remote sensing technology. I think with these words, I think I once again thank Dr. Srestha for his hard works to make such a good presentation, and which will be really useful for our country in the days to come. Thank you, Dr. Srestha, once again.
Thank you. Namaste.
Thank you, sir. We have few questions in the comment section, so we will do this section as a Q&A session. So first question to Dr. Tilak is, first we have a compliment. Nice presentation, sir. Will you please elaborate the use of remote sensing in precision agriculture?
Oh, well, this is used mostly in the California side in the United States. Suppose you have like a big farm, and then you like to know that which part is getting enough water, which part is not getting enough water, or which is getting more fertilizer and which is not getting fertilizer, those kinds of things. Then if you even if you look around with your own eyes, you will not be able to see them. But with the remote sensor, you can see that. But that one is a little more expensive because you need to have more accurate type of information, but they can afford it. That one is a good for there. In Nepal, we might use summertime, but I do not see that useful at this moment because our land is too much fragmented. You know, like nobody can have more than a few acres of land, and so the precision, that's what you're looking for, is a good if you have got a really large one and you can spend a little more money. Otherwise, you know, for the normal farmers in Nepal, that might be more expensive.
Thank you, sir. We have another question. What about laws regarding UAV and remote sensing uses in US?
No, that's a very different kind of, the information. That's a legal issue. I'm not very, good at because I didn't have to deal with that. The one thing I know of is that remote sensing also comes with security concern, and so you got to be a little more careful which of the spots of the US you are looking at, because if you are looking at something, there security issues involved. They're not very happy with that one. So the one thing that I have to tell. Otherwise, once, and basically what happens is the information and satellite imagery was available in the market. They are all legal. They are all good. So you don't need to worry about it. But if you got your own satellite and trying to get information which is more precise, then you are in trouble, you know. And if you want, otherwise, the Russians are spying on Americans and Americans spying on the Russians, and all kinds of things is happening over there, which is something beyond our ones. We are not concentrating on security or defense issues, but we are talking about agriculture, forestry, things like that. So which is kind of like different things. However, the theory is the same. It's not that they have a different type of theory, but theories remain the same. Thank you.
Thank you, sir. Thank you very much. There's a message for you in the comment section, sir, for Tilak, sir. I think somebody's asking for your contact because you both are in the same field. Thank you, sir. Now we are moving towards the end of.
Let me answer that question.
Okay.
Our Mr. Mohan Krishna Strategy has all my information. So I'll provide him my email and the telephone numbers. So through him, they can write me email and so on and so forth. So you are most welcome to call me or write me email or something like this. I'll be very happy to respond. This is something of my field, and I'll be so happy to respond back. Thank you.
All right. Thank you, sir. Now we are moving towards the end of the session. I would like to invite Dr. Mitra Bandhu Paudel, Vice President of CDD and Principal of LSEM, to give his vote of thanks.
Thank you, Purnima. Respected Chair, distinguished Speaker, Dr. Tilak Bahadur Shrestha, Moderator, Purnimaji, guests, ladies and gentlemen. On behalf of Center for Diplomacy and Development, I would like to extend our sincere appreciation to our speaker, Dr. Tilak Bahadur Shrestha, for highlighting the significance of the application of remote sensing in Nepalese agriculture. Similarly, I propose vote of thanks to the chair, Ambassador Mohan Krishna Shrestha, sir, the founder, president, Center for Diplomacy and Development, for taking active initiative to organize this program. We are delighted to have your inspiration to be a part of webinar in this difficult time. Thank you, sir. Thanks goes to our moderator, Ms. Purnimaji, the Secretary of CDD, for conducting this program. I would also like to acknowledge the support from Nemun, Khabar Hub, Kitab Yatra, and DC Nepal. Last but not the least, I must thank our guests who managed their time in our program. Thank you, everyone. Have a wonderful evening. Thank you.
Thank you very much, sir.
Thank you. Namaste.
With this, we have come to an end of this webinar. Thank you everyone for watching us and participating. I'm sure this session has been very fruitful and insightful to everybody watching us right now. Thank you very much. Have a great evening to everybody who's watching from different parts of the world. Have a great day, and to everybody who's watching from Nepal, have a great evening. Good night. Thank you very much.
Thank you.